We need it as fresh as it possibly can be. So I realized this is the shortest talking window I will have had in 11 years with Cassandra, and I am not good at not talking a lot. So we'll see how we do. So I'm Josh McKenzie, committer PMC member. I've been working on Cassandra since 2014, February.
Yeah, I'm Francisco Guerrero. I've been working in Cassandra for 4 years, and I became a committer a year and a half ago. So yeah, working on all the ecosystem things like sidecar and analytics.
And I'm Doug Rohr. I have been working on Cassandra since I joined Apple in 2017. A lot of analytics and sidecar related work as well. And I'm also a committer.
All right. So what we're going to talk about today should be pretty simple and straightforward. It's the problem from the context of this presentation. There's a lot of problems in the world, but we're going to talk about just this problem here, the solution to that problem, and then give a little bit of insight into the ecosystem with Cassandra and where it could head in the future, potentially. So the problem I would contend is that Cassandra is isolated. It is a system of record, and it is hard as hell to get data out of it that isn't a point query that you're going in for, right? Or a collection of rows, right? So a point query plus. Now, that being said, because of those ergonomics, it's legendary for its write performance, it's legendary for its durability and its scaling, right? So when you do a write to Cassandra, you're hitting a mem table and you're appending to a file and you're done and you move on about your day. And that means we have immense burst tolerance, which is kind of like spending money on a credit card where eventually you have to pay down what you have done, because in Cassandra, that data gets turned into SS tables at some point down the line. You end up with repairing at some point down the line. You end up with compaction at some point down the line. But you don't worry about that when you write. You just write as fast as possible, and it's great. And since it is a partition key value store, Cassandra is incredibly durable. And when it comes to cap theorem, we fall on the AP side of things pretty hard. And so Cassandra is super, super available, great geo replication with DCs. It's got a lot of really, really good properties. And as I mentioned before, it's really hard to get data back out of it if you're not just querying with the way data is modeled and you know exactly what you're getting. So an example to put this like in the shoes of an app dev. When you are working with Cassandra, if you want to have your data materialized in any other way, the details of your infrastructure leak into your space. And what I mean by that is, so Cassandra, you can throw whatever you want at it. It's going to be great. Can Solr handle that ingest rate? Can Iceberg handle that ingest rate? And what happens in your app when Solr starts to push back? Well, now you're an app dev who is not only having to deal with like all the UX and the affordances on the front side, but now you're having to deal with how your distributed systems are misbehaving on the backside. And a lot of folks complain about that, and I think rightly so. Now, on this slide, we also have analytics there in the middle. Analytics is not a bad actor. The Cassandra analytics library is actually really, really great for being able to do large analytical queries off of your database without really negatively impacting it. But I'm just adding that here to kind of show, like, this is an awful lot of complexity for somebody who wants to use a database to have to take on, just because it's hard to get that data back out. Because this is kind of the architecture, right? There's a big, big wall in the middle here, which is that integration wall. And a lot of different folks in the Cassandra community have written a lot of functionally identical code that ties Cassandra to whatever the things they're doing internally are on their infrastructure, when this stuff could be open source and we could all be working together on it. So one thing I added here on the left, for those of you that may not be familiar, SAI is a storage attached index. And I think, short way to talk about it is it's a secondary index that's not terrible. And if you use Cassandra for a long time, you know exactly what I'm talking about. So SAI gives you within partition indexing with certain kinds of matching, but it's, it's quite limited compared to something you get from like OpenSearch or Solr. So right in the middle there at the top, you see change data capture with a little red X. That's because it is not robust enough yet. And we'll get to why I feel like I can say that. Okay, so what does robust CDC look like? One thing that I will call out here is the way that CDC works in Cassandra. In some ways, pulling from the commit log, it's kind of like a super, super primitive version of the same kind of architecture you see with Kafka, with Pulsar, with other distributed write-ahead logs. We're basically saying we're only going to care about that append-only file in Cassandra, and we're going to use that to feed data into other systems. And so Cassandra 8844 I may or may not have been the author of back in the day. I may have spoken at a meetup about that feature, and people are like, well, how do I do all the 4 things that it doesn't do? And the answer was, we'll get to that when we get to it. And now it's like 9 years later, and I'm up here talking about it still. So sometimes I wonder. But anyway, the things that are missing from CDC in Cassandra today is reading those commit logs off the replicas, figuring out how to do that, deduplicating the data that comes out of those commit logs. You don't want to dump all that downstream, but how do you go and deduplicate that data? The ordering of the data that you're getting out of there is a concern, and then maintenance and cleanup, right? These are files that are going to sit around until somebody else gets them off the system. And if you run Cassandra at any kind of scale, you know that disks filling up is like the stuff of nightmares. So this is just one other way that Cassandra can now fill up your disks, which we do not want. So that's where CP44 comes in to kind of rescue us. This is taking CDC from where it exists in the project today and kind of bringing it into the modern day industry standard world. The initial implementation in CP44 is with Kafka integration. It's not tied to Kafka. If you use other message queues you want to feed it into, you're welcome to, or any other consumers. This design prioritizes at its very, very top level at least once delivery. So if something hits the consistency level you specify, you will get it downstream. And so there's a lot of other things that end up being constrained by that, North Star for the design, which, I think is fine. You can configure the consistency level at which you want that data to go down to the CDC stream. So if you have a use case where CL1 works for you, like the YOLO mode, you can do that. If you want to do CL all, you can do that as well. Depends on how stable your systems are, or if you're replacing 1,000 nodes a day, right? So there's a lot of ways to tune it. It's highly available. So this uses the sidecar with Cassandra, and you have a sidecar running on each of your Cassandra nodes. And one of the sidecars will basically take a leader role and say, okay, I'm going to be responsible for feeding this CDC downstream. And so I'm going to pull the data from the other sidecars, the other commit logs. And it doesn't actually stream all the data. It's like hashing mutations. It's smarter than that. But it does a deduplication for you, so you don't have to worry about that. There is a caveat here for strict ordering. It's within a time window. The way Cassandra works, you can get data an hour later. You can get data that shows up on a replica days later. And so in the trade-off between, do we block forever until we have absolute strict ordering available for everything, versus do we have a window and say, hey, whatever came in within this window, I'm going to give to you in strict ordering. The design goes for option 2, which I think is pretty reasonable. It's also an open source project. If you'd like to go in there and add other functionality, please do. I'll help you design and review it. And the deduplication there gives you at most once, usually, semantics. And again, it's the same kind of problem, right? If you run a repair a day later or 3 days later, or you had a network partition that doesn't come back up, you can get data that ends up in CDC past the window at which it hit the bar that you set. So if you report at CL1, that's the pathological case where you can get data an hour later and it's like, I have no idea what this is, and it'll report it again. Quorum's a little bit less noisy, et cetera. So what that looks like if you're an application developer is, I write to Cassandra. And all of those other problems, well, technically they become someone else's problem, but they become the problem of the people who are experts at dealing with that problem. It becomes infrastructure software's domain to make sure that CDC is working, to make sure the pipelines are good, to make sure everything is healthy in the back end, to make sure that anti-entropy and recovery, et cetera, is all fine. And you no longer have to worry about that way up in the front end where you have no business actually chewing on that stuff because you don't have any way to really, mitigate it. And this is what a modern architecture with an integrated Cassandra looks like. It's a lot simpler than it probably looks exploded up here. I would say cognitively, you can look at everything in green and just say, that's all like the delightful value add CDC stuff. That's just CDC going everywhere, right? That's CDC going into a data lake. That's CDC going into Zipkin, Jaeger, Redis, wherever you need that data to go. Because this is the industry standard architecture to do exactly what people want to do and need to do. So we should integrate with it as a project. And we are. That's why we have a CEP. And it's great. And so that is the really quick bulldoze through my claim on a big problem we have and solution for it. I'm gonna hand it off to Francisco to talk to you about the sidecar, where it is now and where it is and could be heading in the future. And here you go.
Thank you, Josh. Okay. So where does sidecar come from? So we have this control plane that came from CEP1, and the idea was everybody in the community has their own control planes, and the idea was to consolidate into a single unique effort where we could have like a set of features that would allow us to run a control plane that meets everybody's needs. There were multiple motivations. For example, make it pluggable, make it allow you to do things like backup and restore these things that are kind of basic in a database, allow you to manage the life cycle of a Cassandra instance, have the ability to do authorization, authentication. And today we have like mutual TLS, we have JOT, role-based access control that is backed by the permissioning system that we have in Cassandra. We also have the ability to do health checks, bulk cluster APIs. If you need to change the streaming throughput of SS tables across the whole cluster, you can do it through a single sidecar instance instead of going to all the Cassandra instances. Also, the ability to expose the telemetry from Cassandra, the Cassandra process, the sidecar process itself, and the ability to have the observability for ring health, ownership, token ownership. And kind of looking forward, what can the control plane do in the future for us? So we can add more intelligence to the control plane, like make it aware of if a cluster is going under pressure, we can coordinate cluster expansion, or if we have underutilized clusters, we can do shrinks. We can also have integrations with Kubernetes operators. And we can also have the control plane coordinate Cassandra version upgrades with Canary rollouts. And thinking from the cluster maintenance point of view, what if we can have the control plane do the compaction scheduling? So whenever the cluster is less loaded, we can have sidecar coordinate these compactions, and also kind of along the same lines integrate with repair scheduling, and kind of tying back into CP37. And with that, I'll hand it off to Doug.
All right, so we're going to talk a little bit about analytics. And I saw a 3-minute sign a minute ago, so I'm going to do this really fast, I hope. What does analytics do today? We read SS tables from disk or network into Spark, which bypasses Cassandra's read path. We essentially compact SS tables in Spark, remove tombstones, and then build data frames that can be read by external systems. We also can bulk write SS tables to Cassandra nodes and import them, right? So that's kind of the big picture analytics minus CDC, which is partially in analytics and partially not. Well, not enough time. So let's talk about what kinds of things could the analytics library do, and where do we think maybe we move into the future? Today, the analytics reader can filter what bytes it pulls off of a Cassandra host by token range. So it reads an index, goes, hey, I need to jump to this part of this SS table to start reading. I'll read this much and then stop. So we don't have to stream an entire SS table off to Spark, but we can't do anything more than that until you get it into Spark. So maybe we can do some better predicate push down into the sidecar and be a little bit smarter about that. We could read from object storage. There's no reason that the analytics library couldn't read from something other than the sidecar. It's just streaming ranges of files via an HTTP protocol. So other places that we could read from. Coordinated import is kind of interesting. The way the bulk analytics library works today on write is we write SS tables in Spark. We upload them to all the replicas that need them. We import them on each one of those replicas. And then assuming that import succeeds on each one of those replicas or the consistency level that was requested, we then say, great, this one worked. But it would be a lot better if we could upload those to an instance and let Cassandra distribute the data. So we're not potentially going over WAN lines. You're much closer to the data, and let Cassandra coordinate those imports. So you could do things like mark the SS tables as repaired instead of just dumping them into L0 as unrepaired. We can do things like take this compacted data that we already have in Spark and write it out to other data sinks, right? It doesn't have to live in Spark. We might be able to move some of that into the sidecar, for example. Some other interesting things, disaggregated compaction, right? Compaction is one of those things that causes a lot of load on your cluster. Could we maybe hand something else, some SS tables, and say, compact these for me, please, and give me back the result? Same thing with repair. If you look at the way the bulk reader works today, it reads across all of the replicas, essentially compacts the data, tombstone aware, the rest of it, IR aware, and then it could write out an SS table that says, hey, this is the compacted, repaired view of this SS table from all of these replicas. So we could do something different than Merkle tree comparisons. So those are the kinds of things that we think we might be able to do with the framework that already exists in the analytics library today. We do it? All right, so we might not have any time for questions, but we at least got through the presentation in 15 minutes. So any questions? All right. Thanks, everybody. Thanks to everyone who's contributing to the analytics library too. We appreciate it.